Right, this is a new type of sequence. It doesn't go up by the same amount each time. It's not an arithmetic sequence because we don't have a common difference. Here is 3, here is 12, etc., etc. It's known as a geometric series. Okay, and it's known as a geometric series because, although it doesn't have the same difference, it has the same multiple. So if I multiply one term by the same number, I get the next term. Okay. So in this case, the multiple is 4. Okay, this multiple 4 is known as R, and it's known as the common ratio. So in this case, it's equal to 4. Okay. If I want to find the common ratio for a sequence like this, so one way of doing it, rather than just looking by inspection, is to look at the one term and divide it by the previous term, because that will tell you how much I've had to multiply. So in this case, if I do a ninth divided by a third, that's equal to a third. So that's the common ratio. And the one way of finding out if it is a geometric sequence, it should be the same no matter where I choose it. So if I do 1/81th divided by 1/27th, okay, that happens to also equal a third. Because they're the same, I know that R, in this case, my common ratio, is a third. Okay? This is known as a convergent series because the numbers get smaller and smaller and smaller, and we know it's convergent because this is a series we've done before, and we know that if we add that up, it equals a half. Okay? So I can write this algebraically. Okay, so common ratio R, first term A, I can write this sequence down. So my first term, as I said, is A. My second term is going to be A times my common ratio, which is R, which gives me AR. My third term is going to be AR times R, so that's just AR squared. My next term is going to be AR squared times R, and that's going to be AR cubed. And I can carry on that indefinitely. So the power term is one less than the number of terms that I'm looking for. So if I want to find my nth term, in this case UN, which is the notation that we've used before, it's equal to A, which is the first term, multiplied by R, the common ratio, to the power of n minus 1. And we can use this fact to work out questions that might be asked. So in this case, we have a first term that's equal to A. We're looking for the nth term, which is, or the 8th term, which is 8, and we're looking for a common ratio. Now in this case, we're just multiplying by 2 each time, so R equals 2. So I can say that U8 is equal to 2, the first term, times R, and 8 minus 1 is 7. So 2 to the power of 7 times 2, okay? Which is actually 2 to the power of 8. For the second one here, we have a first term of 1. We have number of terms we're looking for is 8, and we're looking for R again. In this case, R is a half because we're just multiplying by a half each time. So U8 is going to be 1 multiplied by a half to the power of 7. Again, it's n minus 1, which is 7. Again, you can work that out. It's fairly easy to do. So in the book, the practice questions for this are questions 1 and 2 of 19E. Have a go at that before you look at the next video.